Welcome, everybody, to another edition of Coffee and Open Source, a place to meet some new friends, have some great conversations, and maybe learn something along the way. I'm your host, Isaac Levin. And if you're enjoying the conversations here, be sure to like, subscribe, follow wherever you're watching or listening. Also, if you or anybody you know would like to be on the show and chat with me, feel free to reach out to me on Twitter. My handle there is IsaacR11, or you can reach me on Mastodon. My handle there is IsaacR11 at fossendon.org. All right, so with that out of the way, I'm looking forward to my conversation with my guest. We were talking about all sorts of fun stuff before we got started, and I'm just looking forward to continuing that conversation. So my guest today is Eric Lippert. Eric, do you want to say hello? Introduce yourself.
Hi, I'm Eric. Thank you so much for having me on your show. I am very much looking forward to chatting with you as well. As I often say, I can talk about programming languages all day, and I often do. Um, so yeah, I was a designer of fine programming languages, and many of them were open source. Not all of them were. And Isaac asked me on Twitter if I would come on his show,
Yeah.
and I was very, very happy to.
Yeah, I love the way you phrase it. Developer or designer of fine programming languages. Like you're making like you're making some bespoke artisanal
That's
programming
exactly
languages,
right.
right? It's so
Yes.
good. Like I hear it, and it just kind of like tickles my brain a little bit. And
Yeah.
I think we're gonna get into a lot of areas of tech, and I'm looking forward to the conversation. And I always love to start the chats with, how you got started. Like everybody loves a good origin story. Do you recall when the first time technology introduced itself to you and you were immediately captivated by it?
Yes. I recall that extremely clearly. I was 8 or 9 years old, and the elementary school that I went to, so this was in the early 80s, if I was 8 or 9 years old, the elementary school that I went to got a Commodore PET in the library. And those of you who are watching this who are a little bit younger than me, the Commodore PET was a big, chunky, green phosphor screen personal computer. It had 4K of memory and a tape drive.
Mm.
And later on, the school got disk drives, the big 5 1/4 inch floppy disk drives. That was very exciting for me. But the librarian would let me stay late after school and type in little programs into the Commodore PET, and I was completely hooked. I started getting books about it. I still have one. Just unplugged my microphone there.
No
Sorry, can you still
worries.
hear me?
Yep, I still can. Yep.
All right, I still have my copy of Practice Your Basic
Oh, wow.
from
Wow.
from the 1980s. Um, and I went through this book recently because I was reviewing a beginner programming book
Mm-hmm.
that frankly wasn't very good, and I was like, people read Practice Your Basic from the 1980s. It's a better beginner book than this one is. But yes, so that's my origin story. Was I started programming after school on Commodore PETs. The PET that we had was a very special one. It had the Waterloo Basic chip. I grew up in Waterloo, Ontario,
Mm-hmm.
um, which is where the University of Waterloo is, and that was a big site for development of programming
Yep.
languages. They spun off a company called Watcom that I worked at when I was in high school. But the people who later went on to form Watcom made a special version of BASIC for the Commodore PET that was on a chip that you could plug in to the computer, and it added structured statements to BASIC, right? So it added proper while loops and proper for
Sure.
loops and that kind of thing that were not in BASICs at the time. And that made a big impression on me at a very young age. The idea that, oh, wait a minute, there are different versions of programming languages, and some of them are better than others. Some of them are better structured than
In-
others. And so that's been
Interesting.
kind of my fingertips, and in my brain ever since then. Like this idea of, well, we can make languages better.
That's fascinating. So I want to sit really quickly on that idea, right? Because I think one of the things that you hear a lot in tech is like the programming language, like at the end of the day, like use the language that fits the tool best, right?
Yep.
And for you to say like some programming languages are better than others is very fascinating to me because, you know, I would expect that you would assume, and this is completely assumption, this is not correct, please correct me, like that the languages that you've designed, you probably thought at the time were not superior, but better suited for particular tasks than other languages. And
Yes.
I'm curious to know, like, when you were first getting into the idea of designing languages, like, what were some of the languages that you saw initially before you got started, like, basic as being one of them, right? Like, what were there
Mhm.
other languages when you were coming up that kind of that you saw and like, oh, I wonder if this was added to this, would it be any better?
Right. Yeah, so let me just address something that you just said, which was
Sure.
very important, which was yes, when I say that one language is better than another, betterness is a predicate that requires you to say what task it's better
Yep.
for.
Yep.
Um, and so that's important to realize. But yes, there were a lot of languages that I experienced growing up. So starting with basic programming on the PET, and then later the Commodore 64, and then later I had an Amiga. So all in the Commodore family of computers. Um, when I got into high school, I got a summer internship at Whatcom, which was the company that
Mm-hmm.
was spun off of the Waterloo programming languages group, research group. Whatcom, it still exists. It's now owned by Sybase, I think. But anyway, they developed compilers for Fortran, for C++, those kinds of languages, and they were well known in the industry for having very high quality compilers. They had the
Mm.
best optimizers and a lot of very clever people working on that project. So they had a program within the local school district to look for computer science students who were doing well in school and who wanted summer jobs. They would basically put us in a room. I think there were 4 or 5 of us, and give us little tasks to work on. And that was where I had used C a little bit here and there, but that was where I was really exposed to, for the first time, a professional working environment with
Mm.
a real debugger and a
Yeah.
real editor. The Wacom tools were way ahead of their time. They had a version of VI, Wacom VI, that was their editor. It was developed in house, and it had tons of shortcuts for it had syntax coloring and all kinds of stuff to make the developer experience better. And this is all 30 years or more later. This is all old hat now, but it was very very novel for the time, and this idea that you could have a debugger and you could step through your program and you could see
Yeah.
exactly what it was doing was amazing to me.
Mm-hmm.
That you didn't have to just run your program, see what went wrong, and
Sure.
then try to figure it out logically. You could actually slow the execution of the machine down to the point where a human could understand it.
Yeah.
Um,
You talk about like,
so that was
good.
yeah.
Sorry. No,
Oh
finish
no,
up.
that was yeah, that was very that was what really got me interested in a career in
Yeah.
in working on programming languages.
Yeah, so like that was kind of where I wanted to go, is like, because I imagine you talk to professors or you talk to people that are in the generation before yours, where it's like, oh, I
Hmm.
brought my punch cards to the computer
Exactly. Yeah.
lab, and then I waited 48 hours and I came back and then I had to make a small modification or whatever, right? Like,
Oh yeah, and I
and
and I worked with those people. Yeah.
yeah, and it's, I imagine that transition from having to wait
Mm,
like days, and then instead to, you're talking about real-time debugging, so waiting,
mm.
seconds or minutes or whatever, right?
Yeah.
Like, that drastic change was probably terrifying for a lot of folks, because
Hmm.
because I imagine one of the things is that you could probably get away with being, and this is probably going to be a hot take, but like, you could get away with being like a suboptimal developer if
Hmm.
you could wait like, but if there's an expectation, it's like, oh, you wait a couple of days and you find back, but now it's like you're supposed to ship now, like you can figure out things in seconds or minutes, right? um I'm curious, during that time, like, and to take even a step back, were you naturally curious when you were playing these, Commodore PET games? Were you naturally curious of like the underlying things that made them work initially?
Yes.
Or yeah, so it was almost an immediate thing of like how, like, what is it, MythBusters or whatever? How does this get made? Or is this a
Yeah.
real thing, right? Like, do you think that curiosity was something that you had forever, or is it just specific to computers that made you like super interested or fascinated about how these things have actually worked?
Oh, like I've always been interested in tinkering and taking things apart and figuring out how they work. But there was a seminal moment for me, and then again I can identify exactly when it was. I was in sixth grade, and um, my sixth grade teacher, a guy named Ken Warden, super nice man. I'm still in contact with him on Facebook. He's retired now. Um, he had some educational software that was like a flashcard, teach the kids
Yeah,
math kind
sure.
of
Yeah,
kind of program. Very. I mean, this was in 1980, so very very straightforward, simple program written in BASIC. And sometimes the answers would be wrong,
sure.
which is not great for an educational
No,
software
no,
program.
no.
And Mr. Warden said to me, he said, can you figure out why this program sometimes gives the wrong answer to some of these questions? And I was like, well, I don't know. It's a pretty complicated program. So I started reading it, and I remember there was a moment where there was some line of code that said, it was, I don't remember exactly what the line was, but I'll give you the flavor of it. It was like, if X is greater than Y, then
Sure.
X plus 4, right? And then the next line was, uh, if Z is greater than Y, then X plus 4. And I was like, wait a minute.
Yeah, why? Why are we
We've
doing
we've
this?
we've violated the pattern here,
Yeah, yeah,
right?
yeah.
I was expecting, X, Y, X, Z, Y, X. No, I was expecting Z, Y, Z, and
Yep.
I made the change, and the program started working. Now, the thing that I think back on that now was I did not understand
Ah,
what the problem was, but I recognized a pattern that was likely to be buggy. And then
mm,
much, much later on, when I worked at Coverity makes software that does that. And they specifically make a static analyzer that looks for that defect, that
yeah.
looks for, I had a piece of code and I cut it here and I pasted it here, and then I made update, 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 and I forgot to update one of the things. And now the logic is wrong.
So,
So I was quite amused that this process that I did when I was, 8 or 9 years old has now been automated.
you were introduced to the idea of bugs almost immediately then,
Oh
right?
yeah,
Like, yeah,
yeah,
which is fascinating because I think one of the things that when I talk with people that are getting started in tech, it's like you have to be okay with a little bit of pain and that having to navigate obstacles in order because the if your app builds, your app compiles, your app runs, like that's like a high, right?
hmm
And you live off that high for however long till the next bug,
a
and then
little
you just
little dopamine
yeah,
hit. Yeah,
yeah, the rinse repeat, right? Like, I imagine that even though you didn't know what was going on, you solved a problem,
yeah,
right? I imagine that initial thing was very um it accelerated your want to learn more, I'd imagine,
yes,
because you
it
felt,
absolutely did.
because I remember, like, I got started, like, this dates me a little bit, like the first, like, in high school, like my first thing was doing like HTML and CSS and JavaScript, right?
hmm Yeah,
And like making the web page look the way that I wanted it to, like, you jump up in the air, you pump your fist or whatever, right? And it pushes you forward. And then
yeah,
you move on to like other like object oriented languages or functional languages, and you find out like, oh, like I can't even get to the point where I see stuff if I don't do it right. Because if
yeah,
HTML, like, more than likely, like, it'll always show something, right?
right.
Um, and the reason why I'm bringing this up is like there's different flavors of languages, right? And like you talked about basic, and did you ever play around with like COBOL, Fortran, those sort of languages at any point, or did you kind of go from basic to that next wave, which eventually led to C and C++ and so on?
Yeah, I was always using what I would think of now as procedural languages.
Yeah,
Very very straightforward imperative languages where you give a series of instructions to the computer and the computer follows them.
yeah,
It wasn't until much later that I gained. It wasn't until I went to university that I gained any kind of appreciation for functional languages.
Hmm.
And it wasn't until I started like you did when I started playing around with the World Wide Web for the first time that I started to appreciate the power of declarative languages,
Yeah.
where you just say you don't give the computer a series of instructions for making toast. You just say, "I want some toast," and then the
It-
computer figures out for itself
yeah.
how to
Yeah.
give you that toast. Yeah.
Yeah, like the first programming language that I proper programming language. No, not that HTML isn't a proper programming language, but whatever. It was Ada, and
Hmm.
that was like the first one that I started, and I remember thinking like, oh, this isn't too bad. And then like the second programming language I learned was Scheme, and I
Hmm.
remember like, why are they so different? Like that was the
Hmm.
first thing that hit my, and I tried to ask my professor at the time, like, why are these so different? Like, why are we doing these things in so different ways? And he didn't really have a good answer. Like he was like kind of like a cruffy old professor, and he's like, well, because you
Hmm.
need to solve different problems. And I'm like, that didn't register in my head at the time.
Right.
And I'd imagine for you, who you started with something like Basic, and then you went on to other languages eventually. Like when you went to other languages, did they register as quickly for you as like the ones you had learned before, or was there a sharp learning curve for you even?
For me, I remember distinctly um, having a conversation with my friend Craig, who is we went to Waterloo together, and he's now a professor at Waterloo. We had both worked at Watcom. I worked on the when we went to work for Watcom um, as university students. I was working on their database project, and he was working on their C++ compiler. And I remember saying to him, "It's just like I just don't get why anybody would want to encapsulate why they would want all of the complexity of encapsulating
Mm,
functionality and data into objects, right? Like
sure.
that just did not click with me for the longest time. And then of course it became my bread and butter,
Yeah, sure. Yeah.
working on object oriented languages. It did click eventually. But yeah, that was definitely a moment when well, and I can tell you what I didn't get. What I didn't get was that the additional complexity, the number of concepts, the concept count that you have to understand to be an effective object-oriented programmer, is a consequence of the fact that object-oriented languages are designed for large teams working together to solve complex problems,
Hmm.
problems that have complex business domains. And so that you need to be able to say, okay, this piece of code over here, you don't have to worry about how it works. You just know that it does work, and then you can treat it as an abstraction. And it just hands you, an object that you can communicate with over a defined interface.
Yeah,
And that only buys you value when you are in a situation where there are many, many people and a lot of code, far too much for any one person to
sure.
understand all of it and still be productive. Um, once that clicked for me, then it became very clear as like why the language is designed the way it is. There's still a lot about the design of C++ that's could be improved upon. But of course, that's what we did, right? We spent decades and decades improving upon that with all of its successor languages. And then for other language paradigms, like when I started learning functional programming in university, that just made complete sense to me.
Interesting.
That yeah, your experience with having a crufty old professor just say was, oh, well, there's different there's different jobs, and so they need different tools. Though that's true, I would have expected a more professorial answer,
Yeah,
right? To say, well, this gets to the church Turing thesis, right? This
sure.
idea that there are different models
Yep,
of representing computations, and that at a fundamental level, every model that we've ever come up with that we can actually implement in a machine is in some way equivalent to each other, right? There's no program that computes some result in a
Yeah.
functional language that you can't also compute that result in an
Sure.
object-oriented language.
Yeah, and I think yeah, I probably asked the question incorrectly,
Mm,
like anything, because like I took more advanced classes that were basic. Scheme was kind of like the primary
mhm,
driver. Like whenever you're doing like finite state automatons or things like that, like
mhm,
recursive functional languages are very powerful to do those sort of things, right?
yeah,
And that made sense to me. Like okay,
yeah,
like I tried to do the math. Like if I tried to do this in like C++, like it would be very hard.
mhm,
It would not would and I think that was one of the things that I appreciate about functional and languages like Scheme that were like based on recursion is like the idea is like let's just try to make this as simple as possible. And you talk to people that's like, oh, if they've never heard of Scheme, like the idea is like it's just recursion by nature,
yeah,
which for a lot of folks is like I don't get that. But I think
yeah,
it made sense to me. You asked me to write
yeah,
something in Scheme today, I'm hitting up like the Scheme 101 book, right?
sure,
But at the time, I remember like the funny thing about Scheme was that like if you didn't write your program properly, you could do terrible things. Like I
mhm,
remember the professor was grading our homework, and he said jokingly like, "Oh, one of your programs that crashed my PC,"
yeah,
right? And like that to me was like, oh, okay, there's lots of power in this, but also like you could do things horribly and it just goes bad very
yeah,
quickly.
yeah.
I'm
Yeah, Scheme does not restrict you from writing bad programs.
yeah,
And
yeah, yeah,
one of the core ideas of modern programming language design for designing line of business languages is restrict the kinds of programs that can be written to
yeah.
only the good ones.
Sure. Yeah, but I think, I hear people talk about like the different layers of abstraction, right? Like if you want to go all the way
Mhm,
down to the interpretive language or even like the machine language and then go up and
mhm,
up and up, right? And then as you get higher and higher up the stack, you lose control, but you also have far more guardrails to protect you from
right.
doing things, right? Like even
Yeah.
today, right? If you talk to folks that have never built and like written anything in C before, like the idea
Mhm,
that you're like allocating memory and doing weird things, like people look at you like, why would I ever want to do that?
yeah.
Right. So, I think it's very fascinating that, we, not to say that we've kind of moved away from like the idea of giving developers like unlimited flexibility to build things by increasing like more and more restrictions. We've also like invented, like, we've created like this path of like, developers don't know a lot of intrinsic things about computing. And I'd love to get your
Mhm.
thoughts as like somebody who designs languages, right? And we don't have to delve on this for too deep. It's like, are we at a point now where we're abstracting so far from like the actual sand doing smart things
Mhm.
that are we losing a lot of like base level computing knowledge?
Yes and no. I think that it is important that when you are designing a language to attack a particular kind of problem, that you
Yeah.
enable the developers in that language to express the solution in the jargon of the problem.
Okay.
And you can, it's very easy to say, it's like, well, we're so abstracted away from the machine that it's going to be, everything's going to be fat and slow.
Sure.
But if you're clever about your use of abstractions, you can still get excellent
Hmm.
performance out of very high level languages. And one of the ways that we do this as designers of high level languages is by not over specifying how the machine, how the compiler or the interpreter or whatever it is going to come up with its answer, right? You give it a great deal of flexibility
Yeah.
to generate the code at the back end, and then you put enough smarts into the compiler, and you can end up doing quite a good job.
Yeah, it's fascinating to me because I think now, and we can talk about like current technology a little bit later, but like now you have like this idea. It's like, I'm really building an app that sits on top of a stack that sits on top of another stack that is actually
Yeah,
compiled with C that does
yeah,
these things, and then it's like, all the way down. And, to the actual developer, they're just moving bits around on a screen, right?
hmm,
Or even if you go to like the citizen developer or load code developer, I'm just moving like boxes around,
yeah,
which I think is pretty fascinating. Okay, so I want to kind of rewind back to like you mentioned a bit earlier, like the ability when you had an epiphany of all, like, there's a career in designing
Mhm.
languages.
Yeah.
So, you know, I imagine that you had probably a couple of paths. Yeah, somebody who was in the, in computer science doing these things, right? Like, you can go into industry, or you can
Mhm.
kind of go into kind of the more theoretical side of things and like learn more about compilers and learn more about language design. Was there like an inflection point for you where it's like, I just enjoy how languages are built more than building apps?
Yes.
Yeah.
Yeah. The inflection point for me was in my third year of university, probably. So Waterloo has a cooperative education program for math and engineering students, where instead of going to school for 8 months and then having the summer off, and school for 8 months and then having the summer off, instead what you do is you go to school for 4 months, you work for 4 months, school for 4 months, work for 4 months,
Mm-hmm.
and there's a whole bureaucracy devoted to finding industry jobs
Yeah, yeah.
for co-op
Which is
students
great.
as interns.
Which is great, right?
Yeah,
Because I think the number
yeah,
one thing
it's
college
amazing.
kids worry about is how I'm going to get a job after I graduate.
Right. So my first three work terms were at Whatcom, where I had already
Yep.
worked in high school. So that was uh, very safe choice for me, and it was in my hometown. I could bike to work and whatnot. And I worked on the database team there. But like I said, I had friends who were in the language space as well, so I was keeping pretty close eye on that. Then when I went to work for Microsoft as a co-op student, I was uh, sort of randomly assigned to the Visual Basic team, and that's where the heavens sort of opened up, and it was like,
Sure.
oh, now that I've lucked into this position of being on a language design and implementation team, that's where I really started to see how that sausage was made and how they were solving problems to build the tools that I had been using at Whatcom, because I was a Visual Basic programmer at
Sure.
Whatcom, Visual Basic and C. I was writing a little VB front end to one of their database products. So actually getting to see is like, oh well, this is how Visual Basic works behind the scenes was eye opening for me, and seeing what problems they were solving that they thought were hard and
Mm.
why they were hard. So the best example of that I have is in VB2 or something like that. Every line of code is on a physical line of the screen,
Yeah.
and they had made the later to be determined rather serious mistake of building the editor with that assumption and the
Mm.
compiler with that assumption and the serialization model with that assumption. And when they realized this, oh, people are writing lines that are 200 characters long, wouldn't it be nice if we allowed them to break it across lines? And so, well, we'll let people put an underbar at the end of a line, and that will continue the line onto the next character, and they onto the logical line onto the next physical line of the screen. And that one change took the developer that was working on that. It took her months,
Oh.
months and months to find all of the places in the
Yeah.
code that had an assumption that lines of code fit on one physical
Sure.
line. Um, and so that really made me take notice of, it's like, okay, decisions have long-term consequences,
Yeah. Yeah.
and
Yeah.
we should. That was sort of my introduction to some of the problems that you get into in the real practicalities of designing programming languages and interpreters and compilers and stuff like that. And there were lots of war stories
Sure.
about things that the VB team did that looked perfectly reasonable when they wrote them, and then they regretted them
Yeah.
badly in the next version.
Yeah. I'm curious to know too, like, I think as a language designer, somebody who's helping build a language, right? There is a bit of, I guess, separation between probably the work that you're doing and the fact that the work that you're doing is affecting thousands, if not hundreds of thousands, if not millions of people.
Hmm.
When did you realize, like, oh, this thing that I'm working on, like, let's just take VB for example, right? You're working on some Visual Basic thing. When did you realize, like, oh, that this thing that we're designing or we're looking to implement, it affects hundreds of thousands of people?
Yeah. That became quite clear when I was on the VB team as
Yeah.
an intern. I remember two incidents in particular. One was a meeting where and to be clear, my role on the VB team, I was an intern. I was basically running their build machines.
Mm,
I was not doing a lot of work directly on the
sure.
core language in my first internship, though that came later. Um, but I remember a meeting where we got the whole team together to discuss some bug that had been found in the language, and the guy responsible for the bug was joking. He was like, "God, I hope nobody ever writes an ambulance scheduling program
Eh,
in Visual Basic.
yeah.
I don't want to be responsible for that." And then shortly after that, there was an incident where somebody had written, and I don't know why you would do this. Somebody had written a industrial robot controller in Visual Basic, and VB had crashed at the wrong moment, and the robot arm knocked over a vat of pudding and covered the factory floor with
And this
pudding.
got back to the like
And
so
this got back to they reported the bug against the
sure,
VB team.
sure. That's
And I
so
was like,
funny.
okay, yeah, actions have consequences.
Yeah, sure, but
But
like you
yeah,
don't hear like if you're like working on the language, you I imagine you hardly ever find out like what the actual like bug presents itself in the real world as, right? Like,
yes,
oh, like this thing it throws an error here, like if you file a support ticket or whatever, like
right.
I'd imagine that at some point somebody's like, okay, so like what does this actually happen in the real world? Somebody's like, oh, like you knocked over a vat of pudding with a robot arm.
Yeah.
Like just
Yeah.
hilarity, right? Like
Yeah.
that's pretty funny.
Well, yeah, and like fortunately nobody was hurt.
Sure, of course, yes.
You
Very
know,
important, yeah.
it was just hilarious. But yeah, we certainly took notice
Yeah,
of that. So yes, I don't recommend that you write a machine controller in Visual Basic, um, or any language that is not specifically designed to write machine
sure,
controllers.
sure,
Machine
sure.
controllers are hard. Um, but yes, that was definitely a moment where I realized it's, oh yeah, lots of people are going to be affected by these choices. And then when I went to much later when I went to work on the C sharp team, that was probably the point in my career at which uh, either the C sharp team or the JavaScript team, one of those two were the point where I was like, okay, yeah, the decisions that we're making are actually
Yeah,
genuinely affecting the lives of hundreds of thousands or millions of
yeah,
professional developers who
yeah.
are like me, and that made me feel really really humbled.
Sure,
Really,
yeah,
it's like okay, we've got to check our egos at the door here and make sure that we are doing the right thing by all of these people who are then going to write programs that more millions of people
yeah,
depend on.
yeah.
Um,
Yeah, it is quite terrifying when you actually think about like, you make some small change here and that
mhm.
affects developers. But developers are
Yeah.
also building apps that do these things, right? Like I I've had people like are in the on the show that are like in the package management space talking about the idea is like, oh, this one little thing that somebody built in their basement 8 years ago is being used by literally
Mhm.
every developer on the face of the earth, right?
Yeah.
um so I'm genuinely curious, like, when you officially like became like a designer, right?
Mhm.
Like, what was that build up like? Was it you just kind of trying to insert yourself into conversations? Did somebody see that, oh, Eric, they have a knack for kind of solving some of these problems? Like, how did that origin start? Like, the idea is like, okay, now Eric, you go from intern doing build machines, running
Mhm.
coffee. I think in your LinkedIn, it's like like rescuing lost baby ducks, like random stuff like
That's
that.
right.
To like, okay, Eric has some skills in
Mm.
thinking about how languages work at an abstract level. They should be doing that.
Yeah. It was a gradual process. So like I said, I kind of stumbled into the Visual Basic team at Microsoft, and I was like, okay, well this is highly suited to the way I like to work, right? These are
Yeah,
the kinds of problems that I like to
yeah, yeah.
solve. So when I finished I did 3 internships at Microsoft, all on the Visual Basic team, and they offered me a job on the basis of those internships.
Mm.
I did interview at other teams. They all no hired me. And so I went to work for the Visual Basic team. And they had just, that was in 96, and they had just spun up a little side team to do VBScript and JScript, Microsoft's
Okay.
implementation of JavaScript. Um, and that was where I actually started working on like core language stuff where there were design implications. We and compatibility
Yeah.
implications because VBScript was not a perfect subset of Visual
Sure.
Basic.
Sure.
JavaScript was its own whole thing. The Microsoft implementation and the Netscape implementation were not quite identical in all of
Yep.
their behaviors, and the ECMAScript technical committee started up around then, and I was invited to join the technical committee as its most junior member, and
Mm.
I mostly just took notes
Sure.
while the Valdemar Horwath and Guy Steele and all of those guys um, did the actual work of arguing back and forth
Yeah.
about what should the language semantics be. But I was paying very close attention to. It's like, okay, this is how we actually design programming languages in industry across companies.
Yeah.
How do we decide what's important for our users? How do we decide when we're making balances between feature richness and robustness and usability and performance and all of these things? What are the things that people argue about? What are the things that people come to agreement on quickly? I was soaking all of that in.
Yeah.
Um,
So I
and then yeah, oh, go ahead.
yeah. So don't finish with your thought. I keep on interrupting you.
Oh, and when I later at Microsoft went to the C Sharp team, that was when they recognized that I had started attending language design meetings when work that I was doing in the compiler, when I discovered like, oh, there's a more efficient way to do this if we make this tiny tweak to the language and that
Mhm.
that kind of thing. Um, so I started going to more and more language design meetings, and eventually they were just like, well, you're here all the time anyways. We might as well just add you to the language design committee.
Sure.
Um, and that's where I really felt like I had sort of arrived. I'm actually in the room with Anders. We had six. Anders and I had 6 hours of meetings a week.
Mm.
It was a very meeting heavy design process, and those were my favorite 6 hours of the week,
Sure.
definitely.
Sure. And so when you got started, like 96, right? I'm trying to think of like programming languages that were, I guess, hot and popular at the time. So I'm guessing like
Mm.
Python, probably to an extent, like obviously Java, Ruby,
Yeah,
like
Java and Ruby were big ones.
yeah,
Python was invented in '93, so it was just starting to gain some
I
traction.
see. Yeah.
But yeah, Java was the big one.
Yeah.
Java was the one where we all took notice and we're like, oh, that's different, right?
Yeah.
Like that is like C++ plus plus if it had been designed by somebody who was working in industry instead of academia.
Sure. And that's kind of one of the reasons why I wanted to bring up like the other languages at the time, right? And we can kind of move on to like the work that you were doing with C Sharp, right?
Mm.
Like how often as a part of the language design process do you look at other languages and how they're doing things and say like, "Oh, I really like how they're doing this particular thing." Or,
Yeah.
"Oh, to call out to what you said earlier, like some languages do things better than others." Like, "Oh, like that doesn't really work for the problems that we're trying to solve in our particular way." Like, how often do you look at peer languages as a part of the design
All the
process?
time.
Yeah.
Yeah. Yeah. Language design is very much a process of looking at where are the shortcomings and successes of other languages and then using those to inform the design of your language. And let's use C Sharp and Java as an example because even now, more than 20 years later, there's still a lot of misinformation about this. Like, C Sharp was not really designed as a response to Java so much I mean, it was a response to Java, but the design uh, problems that we were trying to solve were the same design problems that Java was trying to solve. We were trying to build a better version of C++.
Mm.
The original code name for C sharp was cool, COOL, which stood for C-like object-oriented language. Um, and so naturally, since the C sharp team and the Java team were trying to solve problems in similar spaces, their designs were going to be similar. But a lot of people at the time, Bob Cringely wrote an article that basically said C sharp is Java with the stupid parts taken out, which I thought was funny. But that's not how we approached the design. We did not approach it as a subtractive process of let's start with Java and take out the stuff we don't like. Rather, we approached it as we have Microsoft is a platforms company. Microsoft makes Windows, and it sells a lot of Windows, but Windows is only valuable if there's apps for it.
Sure.
What can we do to make application developers on Windows more productive? Well, they're mostly written in C or C++. There's plenty of pitfalls for those developers to fall into. How can we make developing, forms-based or client server, over the web-based applications easier for that group of people that are important to our platform, and in a way that is, safer and more robust and more productive for them. That was our focus, and the fact that. We of course we looked at Java, and of course we saw where Java had succeeded and where it failed, and tried to make improvements upon it. But yeah, C sharp was not Java with the stupid parts taken out. But yes,
Sure, sure.
every language is a response to all of its antecedent languages that the language designer knows about.
Yeah, and I'm even curious, like even to kind of turn itself back in on it on the conversation, right? Like I imagine as well as the language matures, when you're looking to add new features and you look back, it's like, are we causing problems by introducing this feature, knowing that our entire cohort of users have been doing things a particular way? So the
Yes.
idea of like shipping new features, like it potentially breaks lots of people, right? So how much investigation is done into like the practical like uses of a language, right? And how is that typically done in your
Yeah.
experience? Is it a lot of telemetry? Is it a lot of user studies? Like how exactly do you really find out how people are using a language?
That is a great question. So and it's a complicated question. So
Sure,
let me
sure. You're
unpack
fine.
that a little bit.
Yeah, yeah.
Um, so on the subject of breaking things, Microsoft has, a nigh religious belief that that backwards compatibility is extraordinarily important for
Mhm.
language products. There are times when we took breaking changes in C sharp where there was some program that worked in C sharp N that no longer worked in C sharp N plus one as a result of a change that we made. And we agonized over those. And we were very careful to try to figure out, okay, how many programs is this really going to affect? Are those programs even correct? Right? There are times when we made changes to the language that would have caused buggy programs to behave differently, and we're like, well, the
Sure.
program was
Yeah, yeah.
already buggy. Um, Stuff like that. So that's important. But then there's sort of a higher level concern that you alluded to, which is whenever we add a new feature to a language, that's effort that can only be spent once, right? And there's an opportunity cost to that. Every time you are, you know, putting effort into supporting one feature, that's every other feature in the world that you could be
Sure.
supporting is not getting that effort. And so we thought very carefully about, well, we've got a limited, Microsoft is a wealthy company, but it doesn't have unlimited resources,
Yeah.
and we had a team that had a budget. So how do we spend that budget to make sure we're getting the most bang for the buck? And so that was a lot of talking to users. And I don't know if I think this is still how Microsoft does it, but you have to remember I haven't been at Microsoft since
Sure.
2012.
Yeah.
Um, what we would do is we would gather a group of MVPs, the most valuable professionals, and these are people who were writing books, doing user education, who were influential within their companies or within the industry, but who were not Microsoft employees. And we would uh, once a year we would bring them all together to meet in person, and that was a lot of fun. But also we would just do little focus groups with them and say, it's like, here's a language idea that we're thinking about. Here's the problem space that we want to attack. Here's some ideas we have about how to attack it. What do you think about that?
Mm.
And one of the most frequent bits of feedback we got when we were pitching new language features was, I would use this feature and I would be productive in it, but there's a way for it to be abused, and
Yeah,
my junior colleagues are going to abuse it,
sure.
and then I am going to have to clean up their mess. So
Mm.
please don't add this feature, even though I want
Yeah,
it.
sure, sure.
Right? And that's a very pessimistic way to look at your junior colleagues.
Yeah,
Um, and as somebody who was once one of those junior colleagues, I took a little bit of offense to that,
yeah,
but I also understood where they were coming from. And so we tried to make, every time we added a new feature to C Sharp, we tried to build it in such a way that the MVPs and the other people we showed it to would look at it and say, it's like, okay, well, yeah, that would be useful to me, and it seems safe enough that it seems like you've taken the sharp edges off of it,
yeah,
so
yeah.
that nobody's going to cut themselves with it.
Yeah, I think the worst thing that you can do, and this is an assumption, when you're building a language, you introduce something that you think is going to bring value, and it does bring value, but it also brings a ton of risk, right?
Yeah.
I think that it's funny because you're especially like thinking about C sharp and the folks that are working on C sharp nowadays, right? They're working on 20 years of design,
Mm,
or even any language, right? Like you have years and years of history, and you potentially have users that have been using that language for that entire time, and every minuscule change has to be ironed out. And I think that that's
mhm.
in, an incredibly challenging situation to be in, because you want to bring things like, this is probably meta for folks, but like if you're in the C sharp community, people ask for specific things all the time.
Oh,
And then
yes.
if you talk to the language designers, they're like, well, yeah, we would love to give you that, but have you thought about what happens if this happens? Right?
Hmm.
And there's a balancing act. And, I think that's why, in the last 10 years, 15 years, you've seen an increase in the amount of languages that have been built that cater to a very specific thing. And I'm
Hmm.
curious to know, as somebody who has a background in this, you probably pay attention to when new languages are created or new frameworks. What are some of the trends that you're seeing today with new languages that have been created recently and have gained some popularity? And not to say I think of Go and Rust, right? Even though Go and
Hmm.
Rust aren't like quote unquote new in the grand scheme of things, but they're like new to the popular language community. Like,
Yeah.
so what are some of the things that you see with those languages that you're like, oh, it must be nice, like building a language from scratch with all of this backstory already created?
Mm. Yes, that is certainly the case. Like, it's a lot of fun to create a new from scratch programming language, particularly when you have some idea in mind that existing languages just don't do this thing well, and there's
Sure.
not a good way to take an existing language and make it do that thing well, either for legacy reasons, or for political reasons, or for just the sheer complexity of it reasons. You think about Go as an example, a language that I have no experience actually writing code in, but it seems pretty clear to me that the designers of that thing were like, okay, there's no sort of line of business general purpose programming language that has really nailed the idea of coroutines as a not a thing that was sort of tacked on
Yeah.
afterwards,
It's
but
like
as like a
the core
fundamental way,
principle of the
a core
language. Yeah.
principle.
Yeah.
Yes, yeah. And with Rust, very very similarly, saying, oh, can we capture in the type system, this idea of borrow checking, and eliminating a whole class of defects,
Hmm.
because the compiler simply will not let your program run if it has these defects. And then what are the consequences of those decisions? And lots of people want to create new programming languages. It's super fun to create new programming languages. But then you have to think about, it's like, okay, well, in order for this language to be useful in industry, is it going to need a debugger? Is it going to need a profiler? Is it going to need editor support? Is it going to need how many other things is it going to need to
Yeah.
make an ecosystem instead of just a language? And that's where the expense actually is.
Yeah,
The language design is the fun part.
it also needs to work on all platforms, right?
On Yes, on
Not
multiple
only
platforms. Yeah.
running on all platforms, but also being built on all platforms, right?
Yes.
Like I think there was a point in time for years where it's like, oh, you build apps on Windows and they run on Windows, or you
Hmm.
build apps on Linux and they run on Linux. And now you have like a underlying requirement for all languages and frameworks that you have to be able to build them anywhere and you have to be
Yeah.
able to run them anywhere, even a TV, even your
Yeah.
watch, even whatever, right?
Yeah.
And I'd imagine that makes things substantially complicated because, the beauty of all these different platforms is that they're very different by design. So
Yeah.
when you're building a language or a framework, you have to think, okay, well, if I do file access like this, is this going to work on a TV or a Raspberry
Yeah.
Pi or some other Linux-based device if I'm building it on Windows specifically?
Yeah. Well, and there's two, like that's a really good point, and there's two things that come to mind there. One is that from a strategic perspective, like I said before, in the 90s and 2000s, Microsoft's strategy for developer tools was very clear. Microsoft sells Windows.
Yeah.
Windows needs apps. Apps need developers. Developers need to be productive.
Mm-hmm.
We will make Windows developers more productive.
Sure.
But now, so you might say, well, so why is the C Sharp team going to so much effort to get C Sharp and .NET and all of these things running on Linux? And it's because the strategy is no longer sell more Windows. The strategy, I mean, Microsoft is happy to sell more Windows, don't get me wrong,
Yeah. Yeah.
but the strategy is to grow the services business,
Yeah.
and Microsoft sells services that have to run across a vast ecosystem of that's not homogeneously Windows
Mm-hmm.
everywhere.
Yeah.
Um, so that's one thing, and then the other thing from a language design perspective is if I were tasked with designing a programming language that had to run on everything from web servers to video game consoles to gas pumps to televisions, Java is not the language I would design, but when Java was invented, that was what they
Yeah.
said it was for.
Yeah. Yeah.
They had this idea that by virtualizing the runtime, they were going to be able to run it on all of these devices. But it always struck me as not a language that is optimized for running in low resource or low
Yeah.
power environments. I would have designed a different language if that were my goal.
Yeah. I mean, and it's interesting that you know you mentioned like use cases for like I would build an app for that runs this, right? You also what I and I think this is something that's been more prevalent recently, obviously, is languages have been designed by companies that see some language, they like some
Mm.
stuff, and they're like, but I need like this. So they
Yeah.
fork that language and create a
Hmm.
whole new language basically from that, right?
Yeah.
And I'm curious to get your thoughts, right? Like, obviously, use whatever mechanism you want to kind of relay your point. Is like, when is it beneficial to the community when big tech company creates a language to solve some of their problems and then says, "Hey, community, here's this language you created."
Hmm. Oh, we thought about that a lot when I was on the C Sharp team. So when I was on the C Sharp team, we knew that we were someday going to open source the C Sharp and Visual Basic compilers.
Okay.
They did not do that before 2012 when I left the company, but it obviously it did eventually happen, and
Sure.
all of that code is open sourced. And something that we worried about was, are there going to be forks of C Sharp that where it splinters into many incomprehensible
Yes.
dialects.
Yep.
Um, Now that seems to have not happened. One of the sort of counter strategies to avoid that scenario was we looked around Microsoft and we saw that there were over a dozen implementations of C sharp parsers.
Mm-hmm.
None of them were correct. And they were all sort of like thrown together by teams that had to write a little analysis tool or something like
Yeah.
that, or
Sure.
a little expression evaluator or whatever, for their own use cases. And they happened to be familiar with C Sharp, so they did that. So that was why we built Roslyn. That's
Yep.
why we built a compiler as a service to say it's like, no, here's a library. If you need to parse C sharp, if you need to do any kind of analysis of C sharp, there's a canonical way to do it, and it will always be correct and up to date. And I think that is one of the value of that. I think has caused people to resist this idea of, well, I'm just going to fracture the language into
Yeah.
whatever I want. Now, if for research purposes, you want to say, oh, I want to take the C sharp code and I want to make my own version of C sharp that adds this feature to see how it works. I strongly encourage people to do that. There was a research team at Microsoft for years that made a language called C Omega that had a whole bunch of ideas in it, many of which eventually did make it into C sharp proper. Um, and yeah, that kind of experimentation, I think, is a very powerful benefit of open sourcing your language.
Yeah, I think the idea that I think also the idea of doing things out in the open too is very fascinating to
Hmm.
me, right?
Yeah.
Like not just like having the language or the specs of the language open, but also like the conversations,
Hmm.
right? Like you see a lot like all these programming languages now like they have a GitHub repo or what have you that's like
Yeah.
they put in the minutes for their meetings.
Yep.
They want to have conversation with the community, and I think that that level of it's not dogfooding per se, but that level of like very early discussion with their users is very beneficial. And I'm curious
Right.
to know like when you do things like that, is the goal always like the customer is always right? Or is it, well, we really want to get this point across, or maybe we have an internal customer that needs this particular thing.
Hmm.
The community is important, but like it's not that important. How often does that?
Yeah,
Yeah,
that's so again, I have not been personally involved with these kinds of issues at Microsoft. I did a little bit when I was at Facebook,
yeah,
but not a lot. But yes, that is something we think about, right? So I said before, it's like, well, we get before 2012, we got feedback from a group
yep,
of industry insiders, basically. Well, now, as you point out, since this is all open sourced and all of the design notes are there, you can get feedback from anybody.
yep,
And on the one hand, it is super valuable to get feedback from people that are motivated enough to actually, type a comment into, into the repo, and have their opinions expressed. On the other hand, we don't know whether that is just one person that has some pet idea that
yeah,
they've always wanted, or if it represents a much larger class of people
sure,
who have a problem that is sort of across the industry. So teasing that out is the job of a good language designer and good language PM. Yeah, it's certainly not the case that the customer is always right. Um, Something that I often say, when we were designing C Sharp 3, which had link in it,
yeah,
very large, complicated feature, we would show that to that group of industry insiders, and the result was almost always the same. They almost always said, I had no idea that I wanted this,
yeah, yeah,
right?
yeah,
But now that I see it, boy, do I want it.
yeah,
Uh,
yeah,
and that really came about as a long design process where Anders has excellent taste. Anders Helsberg, the sort of lead designer of C Sharp back then. He's working on TypeScript now. Um, Anders has excellent taste. Eric Meyer, who I worked with for many years at Facebook and Microsoft, really brought in the academic approach to saying as okay, query comprehensions are a thing in research languages, and here's how we can add them to C Sharp and make it work in the type system. Really marrying all of that together in a way that felt like it was still natural in the language was a sort of a triumph of the
sure,
design process.
yeah,
I'm really really pleased with how that all turned out, and that would not have happened if it was just people asking for their own pet features.
yeah,
There
yeah,
have been releases of C Sharp since then where they've made a list as long as your arm of like, okay, well, here are all the pet features that
yeah,
people have been asking
sure,
for years. Let's just knock them all off now.
yeah,
C Sharp 7 and 8 and stuff like that all had a whole bunch of those smaller features that had been deferred for years and years
Yeah.
that were sort of quality of life, make the customers happy features.
Yeah, one of the things, as we start to, wind up the conversation is like, no, so now today we have tens of languages that I think that at any point in time somebody can pick up and they can start building very complicated apps with, right?
Hmm.
And that's at the language level, and then you have frameworks, and then you have tools,
Hmm.
and then you have all of the things, right?
Yeah,
And I'm
the whole
curious,
ecosystem. Yeah.
yeah, the whole ecosystem, and I'm curious to know like what are some things that you've seen in the last couple of years, trends in the tech space that makes you as a designer think like, oh, how are we going to build the next level of languages to accommodate some of these things? Like we were talking a bit before we got started about like, we're kind of moving away from like the everything is cloud native, Kubernetes is the
Hmm.
solver of
Yeah.
everything sort of thing. And now we're in this like everything has to be intelligent, everything has to use gender AI, everything has to use a chat interface, right?
Right.
I'm curious to know your thoughts as to like, you know, what does Eric the language designer think about when they see like all of these tech trends? Do you
Yeah.
immediately think into like, like how do we build languages with these sort of things, or do you think of them as like, just another tool that you can use with some existing language to be successful?
Yeah, that's a hugely complicated area,
Yeah, sure.
and let me approach that, starting with my sort of personal experience working at Facebook, and then we can sort of
Yeah,
imagine more stuff in the future. The job that I was working at for the last 3 years, I was at Facebook, was designing and it's not really a new language. We thought of it as a new language, but really it's an extension to Python.
hmm
So designing some extensions to Python that would allow data scientists to express certain classes of statistical problems as Python programs, right? So to say we got a bunch of random variables, we got a bunch of quantities that are varying in some way that we can understand sort of the shape of, we know where the means are and the variance
sure,
and all of that. We know which ones are coin flips and so on. Um, we've got some statistical process, and the way those values all relate to each other are by, well, we can just write a little Python program that says, oh, this value is if this coin flip is true, then it's the sum of these two random things. Otherwise, it's the sum of those two random things, and so on. Uh, so can you express those problems in Python programs and then say to the runtime, here's some observations of the real world. Here's some
mm,
observations of how some of those coin flips turned out. How does that affect your posterior probabilities of these statistical distributions? And there's a lot of math in
sure,
that.
yeah, yeah,
um, but so that's what we were working on, was a tool for data scientists to much more succinctly express models in a language that they were already familiar with. They were already doing work against their machine learning models in Python. Um, and so that was a trend, right? That we saw. It's like, okay, there's an underserved market here. There's people who are doing this work in probabilistic models, and their results are, they're not able to succinctly express their problems. They're not able to quickly get results to those problems. We can build them a language tool that works in that space better. So that's sort of like a very small targeted thing, right? But you can then take a step farther out and say, well, in general, what are we missing
yeah,
with these new tools? Um, so I want to first of all say that I am a very strong skeptic of AI hype claims because I understand how they work, right? Because I understand how these generative models, which really should be called imitative models, they're not generating anything. They're imitating stuff that was
sure,
already fed into
sure,
them. Um, yeah, I understand their statistical properties, and so I don't think of them. I don't think of the intelligence as residing in the the computer that is doing the math. I think
Yeah.
of the intelligence as residing in number one, the people who designed
Sure.
the algorithms. Number two, the people who designed all of the inputs to those algorithms, the vast corpus of intelligently produced knowledge in the world. And three, the people who many of whom are in third world countries and who are paid criminally low wages, the people who actually do the day-to-day work of training the models, right? Those people are all intelligent and they're applying their intelligence to these things. So I don't see the intelligence of AIs as being inherent in the statistics. But leaving that aside, you raise an important question, right? Which is, how do we build languages that allow us to make use of these tools?
Yeah.
And that's something that we don't have a lot of research on. My friend Eric Meyer, who I mentioned before, he left Facebook a little while after I did. Um, and that's the focus of his research right now is on languages for AI systems. And he is, because he's Eric, approaching this at a very um, sort of rigorous scholarly
Oh,
level
okay.
of how can we design sort of a natural query language that allows you to plug in. It's like, okay, the generative AI is going to fill in this
Yeah.
quantity here, and then it's going to understand that this quantity is related to that quantity over there, and so on. Um, whether it will prove out that generative AIs are actually a useful tool um, is still an open question
Sure.
for me.
Yeah.
Somebody pointed something out. I don't remember who it was. Um, pointed something out on Twitter recently that that style is a distributed property, right?
Sure.
You can say it's a statistical property, right? You can say, write me a rewrite this article in the style of Charles Dickens' A Christmas Carol,
Sure. Yeah. Yeah.
right? And the what is that style? Well, that style can be deduced from the statistical properties of the words in A Christmas Carol and Dickens' other writing. But write me a document that contains a novel proof. Well,
Yeah.
now, right
Yeah.
now there's a correctness problem because correctness is not a statistical property of
Yep.
documents.
Sure.
Correctness is a property of the specific orientation of specific tokens in the document,
Yeah.
and that is much harder to get out of an imitative AI. So I'm still skeptical about the sort of I think the class of problems that these programs will be used to solve. I think it's being oversold right now, but that there's still a lot of value there if we can figure out how to put appropriate bounds on that. And that's a really interesting language design problem.
Yeah. I mean, it is fascinating because I feel like it's a different user experience, right?
Mm,
And user experience not just for the end user but for the developer too, because
yes, very much
the
so.
developer has to learn the language of how to best harness, I don't know if harness is the
Mm,
right word, generate like
yeah,
some of these, like you said, like it's literally just a lot of math and it's a lot of conditional logic and it's
mm,
a little bit of other stuff too, but at the end of the day, like it doesn't do the thing that a human being does,
yes.
right? And I think that's what's very fascinating to me. It's because, you know, you see marketing hype and it's very much like, oh, like this is going to replace developers or this is going to augment or whatever, right? It's like, well, let's see it like let's see it like reverse a string on the
Mm,
first go, right? Without failing.
yes.
You know, all these sort of like silly things. But I think that I'm fascinated to find out like how the implementations of them work. Like
Mm, it's
generating
very interesting. Yeah.
boilerplate is very valuable to me as a developer,
Yeah.
right? Because I can focus on the things that require only my particular knowledge, um, and I don't want to have to, you know, build a model, a view, and a class for every single one of my
Hmm.
things, right, for the rest of my life. Like I'd rather
Yeah.
just have an AI do that. Um, this conversation has been super fascinating to me. I see that there's so much like ambiguity in language design, not because of the fact that like the problems that are trying to solve are challenging. I think that's fair to say as well,
Mm-hmm.
but also the fact that like you have to respond to all these different stimuli in the world
Mm-hmm.
that a lot of people don't think about,
Yeah, there's
right?
inherent complexity in the tool space. Yeah.
Yeah, exactly, right. And it's fascinating hearing how somebody who has been doing this for as long as you have, think about these sort of things. And I'd love to, as we wrap up, you know, if you can kind of summarize this conversation, and we've talked about, your career to an extent. We've talked about, different areas of language design. I'd love to get, if you only had like a word or two to kind of, conceptualize some of the things we've talked about in the last hour or so, like what would that word or words be for you?
I don't know if I can get it down to
You can cheat. You can
a
cheat.
word.
It's fine.
Um, but in this conversation where we started with the Commodore PET, right,
Yep.
and then with its 4K of memory and its tape drive, and what languages are appropriate for it, and then we've gotten to we now have data centers with trillions upon trillions
Yeah.
of bytes of memory in them, and enormous amounts of compute, and what are suitable languages for that, right? Uh, yeah, so if I had to sum up this conversation in one word, I guess it would be evolution.
Yeah. Yeah.
I think about how this industry has evolved in the 40 years that I've been programming, and it's just astonishing.
Yeah.
And I often feel like I don't necessarily have the right instincts for what is
Mm.
possible
Yeah.
anymore,
Interesting.
because my formative years were working on practice your basic, right, with
Sure.
these
Yeah.
tiny
Yeah.
tiny little programs, whereas kids today who can get off my lawn and
Yeah. Sure. Sure. Sure.
uh, um, never grew up in that world. They grew up in a world with ubiquitous networking and ubiquitous computing, and they are going to be the ones who are designing programming languages that make sense for that world. So I'm very excited to see what's coming next.
Yeah. No, I think that's fair, and I think that it's also very realist to acknowledge the fact that like maybe I am an old hat. Like
Mm,
maybe like I don't have new tricks to learn, but I'm excited to see what gets built. I think there's
yeah,
something there's very genuine about that. So I
yeah.
appreciate you telling me. Um, this has been great. I think for folks that you're not following Eric on Twitter or other spots, like you can follow him on Twitter, for instance, at Eric Lippert. So that's EricLippert. There'll also be some links to some other places, like his blog and Mastodon, some other places that you might find him. Highly recommend if you're curious to learn, some of in a more consumable fashion than maybe an hour and 20 minutes of just ranting about different things, right? um, so as we sign off, my friend, is there anything that you'd like, us to take away from it? Is there any parting words you'd like to say?
Oh, if people are interested in programming language design, there is a new Stack Overflow site called LangDev.
Hmm.
And I've been answering questions there for a few weeks now, and it's super fun. And so if people have questions about programming language design, that is a great place to post them. And I will probably take a look at it, and other programming language designers will take a look at it from industry and academia, and it would be great to grow that community.
That's great. Yeah, no, I'll definitely throw lang.dev.
Langdev, all one word, .stackexchange.com, or
Okay,
I,
cool.
I
So
think that's it. Yeah.
I'll put a link to that in the show notes for
Yeah.
this. So this has been a great conversation, Eric. I appreciate you taking the time, and I appreciate everybody listening in live as well as folks listening in the future. So my name is Isaac Levin. This has been Coffee and Open Source, and hope you enjoy the rest of your day. Take care.